Good morning everyone. I am Rajni from DBS IT College. My branch is ECE and my subject is BW for second mechanical second semester. Last class I was explaining about transistor. What is the first transistor was introduced? So that is 1947 on December 23rd at Bell Laboratories. The first transistor was introduced. So William Shockley, John Gordon, Walter H. Bradley. These three are the inventors for first transistor. Actually, they first introduced FET transistor, but after modern version of the transistor, they developed BJT transistor. So that is a BJT transistor. So BJT means Bipolar Junction Transistor. Bipolar junction transistor. Bipolar means two. Bi means two. Two junction transistor. So here for the device, semiconductor device, they are having first diode. It's having only one PN junction. In case of the transistor, they connected two PN junction diodes. So that combination of the two diodes junction, it is BJT transistor, where the BJT transistor was having two junctions. One is the input junction, another one is the output junction. So the input junction we can consider the base junction and the output junction we can consider the collector junction. Here simply I will take a diagram or representation of the transistor. It is a symbol of transistor, NPN transistor, NPN. So actually in BJT transistor we having the two types of the transistor. Already I explained last class. These two transistors are NPN and PNP transistors. For these two transistors, NPN transistor, where the arrow mark shows the current direction. Arrow mark shows the conventional current direction. Here, this is the base terminal, collector terminal, and the emitter terminal. So for this, we have to take for input one junction, and for output we have to take another junction. Simply I will take for example only. So here it is the negative to positive and positive to negative. Whatever it may be, just I have to take the example only. This is the input junction. We can call as the base junction, collector junction. How we can represent in place of transistor? I will take here collector, base, emitter. So here this is one terminal, another terminal, third terminal. So in place of symbol of the representation of NPN, I will take this is one junction. So collector to base junction, this we can call as the collector junction, and base to emitter junction we can call as the base junction. So these two are the input junction and the output junction. So here the input and output we can consider here, input and output. So based on these two junctions region, we can classify the transistor regions. So we have in the transistor regions basically three types of regions. One is the saturation active region, another one is the saturation region, third one is the cutoff region, fourth one also is there, that is the inactive region. But most probably we can take here these three, or we can consider, that means we are able to see in the characteristics of the transistor active region, saturation region and cutoff region. How we can say it is the saturation region or active region or cutoff region means based on this junctions. So that are input junction and the output junction. So here it is the, we can say this example here, this is input junction. What is the biasing type here? Positive to positive and negative to negative. Both are same, means it is the forward biasing. That is the input junction. Whereas coming to the output side, negative to positive and negative. So that is the reverse bias. So here output is reverse bias, input is forward bias. So here base junction is forward bias and collector junction is reverse bias. In this case we can consider the transistor is in the active region. Suppose here we can take both the forward bias. That means, so this is the negative to negative and positive. So here plus minus. So this is also forward bias. So that means what? Base junction and collector junction. Both are in the forward bias state. So this is forward bias and collector junction is also forward bias. So this region we can call as the saturation region. Suppose this is negative, positive to negative and positive. Again here also positive and negative. So both are reverse bias. So when both are reverse bias condition, so it is the cutoff region. Both are reverse bias condition. That means the input junction and the output junction both are considered as reverse bias. At this condition, the transistor is in the cutoff region. Next, forward bias is same, reverse bias. Input junction is reverse bias and the output junction is forward bias. Negative, positive. So here this is forward bias. It is exact opposite of the active region. So here where input junction is reverse bias and the output junction is the forward bias. In this condition we can consider the transistor is in the inactive region. But we are able to see here only three regions. What are that? Active region, saturation region, cutoff region. But we have another region, inactive region. Here, what are the applications of the transistor? Transistor applications. So based on this also we can consider here the transistor applications. When it is in the input junction is forward bias condition and the output junction is the reverse bias condition. At this time, for this condition, the transistor application is an amplification transistor or amplifier. We can consider the amplifier. So this is the active region condition. When the condition is satisfied, the input junction and the output junction both biases, that we can call as the transistor is amplification transistor. Whereas these two conditions, that means saturation region and cutoff region. So these two states, when both are in the forward bias condition, means the transistor is in the on state. When both are reverse bias state, the transistor is in the off state. When it is the on and off, means the device we can consider it is the switch condition. So we have to take here switch. So the transistor applications are major application is the amplification transistor, and it also we can consider the another application for transistor is the switch state. So these are the regions. What are the regions we having? 4 regions, but we are able to see in the transistor characteristics: active region, saturation region, cutoff region. We having bipolar junction transistor, 2 junctions, base junction, collector junction. The input junction is in the forward bias condition and the output junction is in the reverse bias condition. So at this condition, the transistor acts as an amplification transistor. Whereas in saturation region, the input junction is in forward bias condition and the output junction is in the forward bias condition. Both junctions are forward bias condition, that is in the device is in the on state. Whereas cutoff region, both junctions are in the reverse bias state, that is the off state. So these two states we can consider on state and off state. The transistor will act as a switch. So we have to take transistor applications. One is transistor as an amplification transistor. How we can consider the transistor is an amplification transistor? We can see here. Transistor is an amplifier. Basically, the transistor major application is the why we can introduce the transistor means it is the amplification transistor. When the transistor condition to both junctions are and input junction is forward bias condition, output junction is in the reverse bias condition, and both conditions are satisfied, that is in the active region. When it was in the active region, the transistor is an amplification transistor. Actually, the transistor is transfer the resistance. So here we can see these words: trans. So here transfer the resistor from low region to high region. That means what? We can give the strength for weak signals, amplifiers. So that is amplification Here, this arrow mark shows the current direction. It's having the emitter current IE and it's having the collector current IC. This is the base current. We can see here amplification factor. What is amplification factor means? The amplification factor we can define the ratio of IC by IB, that is output by input, whereas the base current changes and also the collector current changes to the base current changes. That we define the amplification factor. So here IC, IE and IB. IB is the small current. So IB flows the small current. So here IC is it flows the large current. So the transfer the resistor from low to high. So low region to the high region. So it will be having an amplification transistor. How? We can see here example, whereas IB and IC. It is the for units IB means microamps and IC means it's having the milliamps. So micro means what? 10 power minus 6. Milli means 10 power minus 6. Suppose 0.1, 0.2, 0.3 microamps for base current. Likewise, we can see here IC 2 milliamps, 4 milliamps, 6 milliamps. Likewise, we can see here. How the changes we can consider from the base current, it changes from point 1 to point 2. So how many points are there? Only 1 point. So point 1 to point 2. Likewise, point 2 to point 3. But in the case of the IC, the change is from 2 to 4 or 4 to 6 or 2 to 6 means it is having a large amount of changes. So here we observe this large amount of changes we can consider the amplifier. So amplification transistor. That means practically we can observe like this. But because of theoretically we can say when it is in the anti-division, the input junction is in forward bias condition and the output junction is in the reverse bias condition. Then we can say the transistor is an amplification transistor. How we can observe practically means we can take these values. For example, we can take these values. For IB, microamps means it's having very smaller values. So the changes also we can consider the small values. Whereas in the case of the IC, it's having the large values. The changes also we can take the large values. So IB and IC. So both we can consider here. Or we can take here simple graph IC and IB. So here the slope is like this. So it is IC and IB. So microamps, it is the milliamps. So the slope means it will be increases linearly according to the base values. We can see here collector current values. The changes will be large changes. So we can take here the transistor as an amplified transistor. Or we can say the condition is whereas the input junction JB is in the forward bias condition and the output junction collector junction is in the reverse bias condition. It is in the active region condition. Then we can say transistor is an amplification transistor. That is the amplified transistor. So this is the major application of the transistor. Next, another one is the transistor as a switch. Transistor as a switch. See, we can take a simple graph linearly moves IC and here IC. Simply, I will take here the CE configuration of the BJT transistor. CE configuration. So we can take the circuit diagram and CE configuration, base, collector and emitter. So emitter terminal, collector terminal, another one is the base terminal. So what is the condition? Input junction is in the forward bias condition. It is a NPN transistor. For NPN transistor, positive to negative. So that is the forward bias condition. And we can take here the output junction is in the reverse bias. So negative to positive. So it is the reverse bias condition. It is the reverse bias. Here the current we can take here IE, IC and IB. So simply I will consider here the output characteristics of the CE configuration. So for that here this is linear region and here up to this is the IB is equal to 0. So this region we can consider cutoff region. So here how we can divide the regions. So the regions we can take here. This is saturation region. First we can see it is a forward bias condition, reverse bias condition. The transistor acts as an amplification transistor. And here the output characteristics we can consider is the IC versus VCE. So for output characteristics, output current is IC parameter and output voltage is the VCE parameter. So this voltage is connected to emitter VCE voltage and this current is IC current. So these two parameters and here base current is the constant and IB is equal to 0. Here the IB is equal to 0 means the cutoff region means the condition is the transistor region condition is the two junctions are reverse bias condition. So it is the reverse bias state, it is also reverse bias condition. When both are reverse bias condition means we can take here in place of transistor, we can see the junctions collector, base, emitter. So here the current is positive to negative, so base to emitter. So it will be very small value. So the small current, a small current means we can consider it is the negligible current. So that's why we can say here the below region of the IB is equal to 0. At the same time, at this region in reverse bias condition both are the voltage parameter here VC parameter is also very small value. So here and power is equal to VCE into IC. So this is practically we can consider here. Whereas ideally we can take P is equal to V into I. So it is the small current means whatever current value 0. When it is the 0, what is power value? 0. So there is no power loss. So we can say here when both are in the cutoff region state, it is the no power 0.1, 0.2 likewise increasing. At the same time, the load current, so it will be resisting up to the load current, so it will be some increasing. So this region we can consider the saturation region. So saturation region, cutoff region. Whereas in the saturation region, it's having some voltage means it's having some small voltage. So the device will starts on. So that means what? Ideally we can take here the voltage is here 0. V into I. When it is the 0, what about P? It is also default, it will be 0. So in case of this state also, the saturation region also it will be maintained the 0, the negligible. So it will be considered as the negligible. So there is no power loss. In this case also, sorry, no power loss. Okay, next, whereas the both we can consider forward bias condition. I mean, input junction is in the forward bias condition and output junction is in the reverse bias condition. These two cases we can consider here the linear region is voltage into current. So that means that is the linear region. We cannot consider here linear region. We can take cutoff region. Why? Because of no power loss. So it is the saturation region. So this, when it is the off, the device is in the off state, it will be considered the cutoff region. When the device is in the on state, it will be considered the saturation region. How we can applicable for the switch condition? So that purpose, first we have to know about what is the switch state. I mean switch condition, on state and off state. When it is the on state means it's having the 0 resistance. When it is the off state means infinite resistance. This is switch. How the switch does the switch function we can consider on and off. So the device is in the switch is in the on state means 0 resistance. The switch is in the off state means infinite resistance. So that's why in cutoff region, so here 0 means it will be negligible and saturation region also will be negligible. So these two cases we can consider the device is in the on state and the off state. That's why the transistor we can say transistor is in a switch condition. Transistor as a switch. So this is about transistor as a switch. So that we can take saturation region and the cutoff region. We negligible here this active region.